Hello and welcome back. This is video number 3 for MAPP assignment number 3. This is for Husson University's Speaker Systems Design and Optimization course. So we're to the good part here. We're at the part of the assignment that it's all about, that is angling, articulating the various boxes in the line array to get the best possible coverage. Jumping back to our map file here, if you haven't done so already, make sure you save it, update it, give it a new serial number. I'm currently on map number 303. Let's turn on, if you haven't done so already, under View Centerline so you can really see where the boxes are pointing. I'm going to switch over to the left side preset, and you can see by default the boxes are very much pointing at the balcony. And of course, what we need to do is angle these boxes so that they spread coverage across the venue, and that's what's going to happen in this video. A really big first decision is to talk about height and how tall in the bumper position where the array should hang. Currently, it's hanging at 25 feet. The bumper bar position there is 25 feet off the stage. Is that the right location? Higher is usually better. Higher gives a more equal coverage, make more equal distance between far points and close points in a venue. So usually higher is better. You can run into problems here in the Gracie Theater where you might start splattering energy on the diffuser panel, so you kind of have a restriction there. If you get too low, not only will you have a poor variance of level across the venue, you also may block lights and stuff that are trying to aim at the stage, and that's no good. So we'll go with 25 feet here. I do recommend you play with it. In the assignment here, I'm having you tweak, and mess with the trim height. It's kind of interrelated with the angling process, so it's hard to separate the two, but finding that right trim height, if you go over here on the left inventory, click the Express setting tabs, you can mess with the height here and bring the array up a little bit. You know, this is a foot. Oh, I typed in the wrong number there. There we go. A foot higher or a foot lower or whatever. You know, in the end, I'd stay at 25 feet. It's probably the right thing in this particular case. You also have a rotation point here. It's common sometimes to angle the array. Here, let's angle it by 5 degrees down. This can be achieved at the bumper bar. There might be pins for angling. It can also be achieved by lowering the front motor on the chain motors, the chains that are holding the bumper bar. That's another way to do this. It gets a little bit harder to get the exact angle sometimes. Luckily, at the Gracie Theater, we have lasers that are mounted to the top box, and the laser fires against the architecture and shows you exactly where it's supposed to be pointed. The laser also has an angleometer on it, which tells you the angle of it's at, so that helps out quite a bit. Anyway, play with the angling, but the main thing, one more thing before we get into the actual angling, discussion of the top boxes and where they should point. It's a kind of general approach to take a box or two and fire them across the top of the highest seat. We call this what's it called? Aiming factor or overshoot. By having one or two boxes overshooting the back of the audience, this makes sure coverage is consistent all the way to the top of the audience. So we're going to try to do that. And let's get into the angling here. Anything more I can tell you before I jump in? Oh yeah, the general theme here, written in blue. Really, when you get into this angling process, your initial goal is to make sure that all of these lines land equidistant across the seating plane. So you're going to try to make, and let me scroll down here and give you an idea what this looks like. Something like this, where the lines are relatively equidistant on the audience plane. And that will give the most consistent variance, the most consistent frequency response in the high end across the audience. So in order to do that, in order to get those to angle and to space those out appropriately, you're going to end up using smaller angles at the top and larger angles at the bottom. And this is because small angles over longer distances expand to cover larger distances. And larger angles, when they're over shorter distances, they don't necessarily have enough distance to expand to be as large. So that's what's going on here, basic geometry. So we'll start doing some guesswork here. Maybe I'll make the second box be 2 degrees. See what I'm doing there? And now I've got 2 firing over the head, and maybe I'll make the third box 2 degrees. And you just kind of have to guess this at first and just make an attempt here. I'm going to do 3 degrees, maybe another 3 degrees, and I'm just going for it because you know what? I can go back and fix it all I want. 5, maybe I'll jump up to 6, maybe I'll get to 7, and the last one we'll go with a big old 9. And how does it look? Those 3, that one looks a little bigger, and these ones will look a little smaller than that. So I might want to start going back in here and going, okay, let's go to 3 a little sooner here. Or maybe that wasn't the case. Maybe I wanted to leave that on 2 here, but maybe I get to 4 a little sooner. And just kind of look at it and kind of make them angles consistent. The other thing I want to think about is where's the bottom box pointed. I'm going to go to isometric view here. I aim to have that bottom box kind of point into the 3rd row, and it looks like I sort of achieved that here. You can see that's good. Hey, while you're at it, see how these the lines, what do we call them? The center lines fire through the seating plane. A nice thing to do is make the lines so that they stop when they hit the seating plane. So you kind of declutters the screen. In order to do that, you're going to have to unlock the orchestra and balcony seating planes, and then you can go over to inventory and turn off through. So we'll do this, and this will make the line stop when they hit the seating planes. I find that kind of useful sometimes. It's up to you, but it's a nice feature. Then you can go back and be sure you lock them. When you lock the seating planes, MAPP actually predicts faster, which is kind of odd. But now you can see that the line stops at the 3rd row. So my first shot here, I'm pretty good, you know, it's all right. And I do have my 2 overshoot, and my bottom box is aiming where I want it to be. How's it predict? You definitely want to predict. You don't want to just do this blind. It isn't just about the lines. You can, let's do a little prediction here. Actually, before you do it, let's go back, grab the array, and let's turn on section plane, that side view, and then predict. And I'm predicting at 8 kilohertz right here. So that's kind of cool. You can kind of see what's happening. But more importantly is what's happening. I'm going to turn off section plane now. That's actually distracting. It's kind of cool to see the energy, but it really doesn't help me see coverage very well. You can see that there are hotspots, which, by the way, is totally expected. You know, those are the areas between the boxes where they're coupling together. Other things you might see is that it's louder down front because you're closer to the boxes, and it's louder at the beginning of the balcony because if you actually rotate this drawing around, you'll see the balcony is also is closer to the boxes. So under the balcony is quieter. So what do? Well, you start playing with this and start changing angles and go, okay, maybe if I separate these 2 a little bit more, or maybe there'll be a little bit less of maybe I can take care of the hotspot. Or maybe if I push them closer together, there'll be more or less of a hotspot. So I'm going to leave that tweezing to you. I'm going to let you play with it and see if you can get any better results. But again, the initial goal is to try to separate them so that they are equally spaced and then do a little bit of tweaking. What else did I kind of miss in the instructions here? I just want to make sure I have not missed anything. Yeah, bottom box, aim at head height at 3rd row. Top box, have 2 boxes overshooting. That's pretty normal. Turn off the throughs so you can see the lines better. And there you go. It's not, definitely educate yourself. Take a moment and do predictions at different frequencies. This is also a time when it might be kind of convenient to turn the section plane on, because it's kind of interesting to see how the array differs in very different octave bands. You know, down at 125, it's basically all coupling and pointing forward. And let's try side view here. It's kind of even hard to see the seating planes here. Perhaps I'll turn off. I'll clear that, remove section plane. I'm still experimenting with their new section plane. I'm not sure how I feel about it. But it is interesting to see how coverage differs at different frequencies. You check out 500. And it's a little hotter there, kind of hot in the center audience. But as we get up to, say, maybe 2K, starting to see a beam there and beam there. So you're seeing very different results at different octaves, and that's part of the line array behavior. So anyway, this is the kind of idea, and we'll pick up on the next video and do some more stuff. But now you know how to do basic line array articulating. Bye-bye.